Hello, everyone. Welcome to Karmada community meeting. Today is May 28th and 2024. Um, Today we have agenda. I'm not sure who gonna be who gonna talk about it.
I think that would be me. I mean, I put that agenda item.
Okay, me Miguel, right?
Yeah,
Miguel,
Miguel.
right?
Yeah, Miguel. Yeah.
Miguel. Okay. Sure. Go ahead.
Do you mind sharing your screen? I don't have access, and I'm connected through the my work VPN, so I don't have access to the doc on my laptop, and I can talk about it.
Okay, you here?
Yeah. Okay. Thank you. So I am part of a team that basically is in charge of the bare metal provisioning and assigning bare metals to well people so that they can use it for different purposes. We do so through Kubernetes operators. So we have a bunch of CRDs that we use to, well, basically accomplish our goals. So we
Mm,
were basically evaluating Karmada. We're not using it to see if it's feasible for our use case. So we basically wanted a unified API in which users can create a CRD that can basically replicate to the correct cluster based on the data center that they wanted their machines on, and that we could also use for like failure scenarios in which we needed to migrate our CRDs from one cluster to another for whatever reason. So
mm,
that we wanted to see if Karmada would be a product that could help us with it, but we found like problems that basically we couldn't be solved. So we just want to see, we just want to evaluate whether it would be feasible to sort of enable a two-way sync mechanism to allow object propagation or CRD propagation. The background here is that for better or for worse, some of our CRDs required us to basically put a status and a status field and depend on it. Sometimes
mm,
we need to populate the spec of the CRD at while it we need to populate the spec of the CRD during the reconciliations, which we understand that is not among the best practices, but there are reasons why we need to do this. And yeah, we also generate other intermediate CRDs that the user doesn't necessarily create. So the user creates one CRD, and then we basically, our controller creates another one to manage a subset of bare metals. But that's an implementation detail. So the problems that we saw while we tried Karmada for our use case is that, well, their spec, basically, if you define a CRD on the Karmada cluster that gets propagated to the worker cluster, and then the worker cluster modifies the spec of that CRD, then there
mm,
would be a constant, basically, a constant fight between the Karmada cluster and the worker cluster, in which one sets the spec, the other one unsets the spec because it's not supposed to be there, and then the object keeps reconciling.
mm,
We basically we also observe that the status, even though it gets populated on the worker cluster, right, it never gets synced back to the Karmada cluster. So if we ever need to replicate, basically move the object to another cluster, then the object will come without status, and then it would put us in a bad situation. There would be issues if that were to happen. And then also the intermediate CRDs are not automatically sync to the cluster. I know that there is a way that you can basically import new CRDs to the Karmada management cluster, but my understanding is that is something manual. It's not something that is constantly watched. Perhaps I'm wrong there. So what we wanted to see if that, well, two things. If one, we could get a way to do like a two-way sync in which the management cluster basically is aware that both the spec and the status have been populated on the worker cluster, and it gets well sync upstream. So that if we ever need to migrate, right, that then all of those fields are already set on the CRDs that we're migrating to the other cluster. And well, also if we can start watching these intermediate CRDs, pretty much if I say, hey, like any CRD of this type, you need to start watching it, then that also gets synced up to the management cluster. Again, like perhaps this is not the intended use case of the product, and that is totally fine. We just wanted to surface these opinions. Hopefully, this is making sense.
Okay, let me try to understand your use case. First, you have a controller who is running in the uh, work worker cluster, right?
Correct. Yep.
Uh, so the controller will generate the other CRDs in the worker cluster, right?
Correct. Yep.
And the when the controller creates actually it will create CR resources, right? And with the spec,
It,
how,
so
yeah,
the controller basically does two things. It creates intermediate CRDs, right? But then it also populates. Sometimes it populates the spec of the CRD that was synced
actually
from the Karmada
this
cluster.
should be the CRs, right?
Yeah, yeah, yeah. Sorry, apologies for the notation there. Yeah,
CRs
it is,
create,
yes.
yeah, I can see that.
There, I'll fix the typo. It's in a bunch of places. But yes, when I say CRDs,
So
I really meant CR.
in your case, you should guarantee the CR's status cannot be removed, right?
Right. Like basically,
So okay.
if I did something on the worker cluster, I don't
Mhm.
want I want it sync back to the parent cluster, and I don't want the parent cluster to, like override it.
The problem here you mentioned that Karmada will uh, clear the uh, here spec gets cleared by Karmada. Why Karmada will do that? I don't understand because the CRs are generated in the worker cluster, and actually Karmada doesn't manage these CR resources.
So I created a CR resource or I created the custom resource on the Karmada cluster, right? And I defined a propagation policy so that it gets synced to the worker cluster. When I created the CR on the Karmada cluster, I created it with an empty spec. And once it gets to the worker cluster, my controller pretty much puts something on that spec.
Mm. So you so the CRD is the CR resource is created in Karmada
In
or the
Karmada.
worker cluster in Karmada, right? And you use Karmada to propagate the CR to worker cluster, right?
Correct.
But the after that uh, the control maybe some controller um, will update the spec in the work clusters, and at the
Mm-hmm.
same time Kamada also manages the CR, so
Correct.
there is the conflict, right?
Correct.
Yeah, I get it. So I think it's a very simple and uh, a very simple case that um, Kamada can handle it by uh, Kamada result interpreter, and can see that interpreter. Yeah. Karmada had the resource interpreter. It can define the behavior how Karmada will sync the resources. For example, uh, for this case, you can tell Karmada how to sync the spec to working clusters. Uh, uh, for example, you can tell Karmada which field you don't want Karmada uh, to overwrite the values um, maybe generates in the work cluster. So that's the
But I don't only want to stop Karmada
mm,
from not modifying the field, but I would like the definition that is on the
mm,
Karmada cluster to basically be sync with what is on the worker cluster. Hence why I said a two-way sync, because it's not only the spec that we need in sync, we
I,
also
I, I, I I know what you mean. You want Kamada to first time you want Kamada to sync the CR to worker cluster, and after that you want Kamada to sync the spec back, right?
and the status.
And status you want to sync back, right? Okay.
Yeah, I think the use case
So
is sorry. If we want to put a cluster in the maintenance mode, and then we would like to Karmada to use some propagation policy to sync that
mm,
the same CR to a different cluster where the controller can start reconciling.
Right. And again, this is sort of like our issue as well, because like CRs should not depend on status, right? And we should not have controllers that modify the spec either. So I recognize that the implementation is also a little bit at fault here. That's why we're not saying that Karmada should do this. We're just asking whether it's a good idea.
mm. For now, Kamada can sync the status back, but for the spec part, I don't know. For the spec part, Kamada cannot do that right now.
Perhaps something to keep on the backlog in case somebody else has a similar use case or a better reason why to sync spec. Like, we're working for our CRs not to be on this situation, but it's not as trivial. Don't know if we would
Mhm.
actually do so.
So the question first I did the see other users has such requirements, but my question is why you want the spec part get synced back to Kamada? I don't get it.
Because if it is not there and we need to migrate the CR to a different cluster, and we migrate the CR and the spec and the status are not in a way that we expect them to be, then we're gonna go ahead and again, for our use case, we're gonna rebuild the machine, which will be catastrophic if this machine is actually being used. We manage bare
Mhm.
metals through these CRs. So we basically say when we need to rebuild them, when we need to give them to users, when we need them to take them away from users. So we have a CR in there called a bare metal CR that if the spec and the status are not in a certain way, we're gonna say, hey, like we're gonna rebuild this machine.
Mm,
Right. So example specific flavor of spec is like the machine operating system type, which network tiers the machine's in. And then our controller will go ahead and reconcile and build the machine into that flavor, and then which reflecting the status. So So we have a whole bunch of these. You can imagine we have a whole bunch of these CRs. And then when we decide to migrate, if it goes to the different cluster and then the spec got cleared, and then our controller in the new cluster would think, oh, there's mismatches, so I'm going to have to rebuild this machine.
Mm. If there is a sample of the CRD or the CR, that would make the easier for me to understand.
Yep. Okay. We can add some example CRs here. Yeah. Okay. I mean, the way we're doing right now is like to handling the more in general, like the cluster, maybe failover case. Because all the CRs
Failover
is
case,
stored
right?
in the Valero, right? So we use Valero to back up in the etcd into some external storage, right? And then we use during the failover cases, we can just
Yeah.
use Valero to restore that into the new cluster where it has all the spec. But it's not going to be continuous backup, right? So there's going to be gap depending on the backup cadence. But we're hoping that if we can do this two-way sync with Karmada, and then it's going to be continuous, right? There's not going to be depending on how often we do the backup.
Mm-hmm.
I feel like this Karmada probably work easily with. I don't know if there's people use Karmada to for like the controller use case, or the CR is kind of reconciled by.
Yeah, I'm still thinking the two-way sync thing. Um, as I said, for now, Kamada can sync the spec down to the work cluster and sync the status back to Kamada. So this way is a general way, and usually don't have too much conflict. And for some case, Kamada can use the result interpreter, the hook named retention hook. You can tell Kamada which field you don't want Kamada to override. But for the if Kamada default to sync the spec back to Kamada, I think that's gonna be a very challenging thing for because Kamada don't know when and don't know it should sync the spec to worker class again. It can Kamada cannot figure out the spec comes from the work cluster or come from the user's configuration. So I mean the two-way sync might be very challenging.
I mean, if there's not enough people doing this, maybe I'm just wondering if we're using the anti-patterns.
Yeah, I mean, like
We're not saying that this needs to be done in Karmada. We're just kind of using it as a consultant.
and and again,
Okay.
and again, like we recognize that the way we handle these CRs is not ideal. Like we're trying to fix it on our side, but it's not trivial. So maybe we can on the long term, but we're not 100% sure yet.
So is
So
that an
Miguel,
option, Miguel, to have an external storage that can be used for reconciliation?
Um, but I mean, if I guess I don't see it with an external storage because then how would Karmada work here? Because then like we wouldn't really need Karmada if we use an external storage, right? Because we can just shut down a cluster, bring up a new one, and point it to this external storage, which would be an externalized etcd, I guess, or maybe kind with Postgres. I don't know, but
Yeah, I think this is like a similar use case to what Spas discussed last time we had a call, right? So it's basically you have a failover scenario and your application migrates from one workload cluster to another workload cluster,
Mhm.
and you need to restart from some state, right? And Karmada doesn't know anything about that state. But if you store it externally somewhere in some storage, right, then you can basically figure out what was the status of your application before failover happened.
I mean, to us, etcd is the external storage, right? So I mean, we could go with the same route. I think DSP, you guys use Dolly or uh, platform API, right?
Yeah.
If we store the source of truth there, I mean, that's once a new cluster stands up, we can just
Yeah,
do the
pointed.
synchronization.
Yeah.
But
Yeah.
we'll give a little more thoughts. I don't
Something.
want
Yeah.
to, yeah,
Something
I
to
don't want to wait.
explore. Yeah.
Yeah, something to explore. I guess the other question that we had, like outside of the two-way sync, is like, is there any planning Karmada to like sync intermediate resources or CRs? Like, I guess an example of this would be, let's say, Ser Manager. When I create a certificate CR, then there's an
Mm.
intermediate CR that is a certificate signing request, right? It's another CR that they support. So is there gonna be any support for this? Like I'm putting Ser Manager as example. That's not why we added it here. We have our own intermediate CRs. You're just wondering like if those can be synced. So basically, if I create one CR and I tell it, hey, like whenever I create a CR, another one is gonna be created. You need to watch for those kind of thing.
Uh, Sorry, I don't get. You mean you take the search manager as the example, right?
Yeah, the Ser Manager is an example. Like in reality, we have a CR called a claim.
Mhm,
Whenever we create
mhm,
this CR called a claim, we also create multiple CRs for that claim or potentially multiple CRs called machine allocations. And we sort of need to make sure that whenever we migrate this claim from one worker cluster to another one, that its underlying machine allocations go with it.
mhm. You migrate what kind of a resource you mentioned?
It's our own CRD called a claim and a machine allocation. So whenever we create a claim or the user creates a claim, we on our controller create a bunch of machine allocation CRs for that claim. So whenever we are in a failover situation, if we need to move the claim CRs to another worker cluster, we need the underlying machine allocations to also be moved with the claim.
Sorry, I still can't get your use case. This is we are talking about is another use case about the migrate object, right?
It's on the last bullet point. The intermediate CRDs are not synced. Should say intermediate CRs.
Mm-hmm.
You see a last bullet point?
Mm. So how about that? How about maybe we can talk about the it by like GitHub issue and maybe you CR the CR sample would would be easier for me to understand.
Yeah, I can create an issue with a concrete example.
Hmm. Okay.
That's probably better.
So okay. The third issue is that you see the things not synced back automatically to
That,
the cluster. Right.
that's the one that I'm gonna create an issue for.
Okay. Okay. Sounds great.
That's all what I had on my side. I guess I'll create an issue for the intermediate stuff.
Hmm. Okay, that's great. I will leave my comments on the issue then. Okay.
Okay. Okay.
Mm, mm.
That's it on my side. Eugene, I don't have anything else. I don't know if you have something.
Okay. So
No, I don't
okay,
think there is
great.
anything else on our side. Yeah, this was the only one.
Okay, let's continue the topic on GitHub, right?
Yep.
Yeah. Thank you so
Okay.
much.
Thank you so much.
Thank you. Thank you.
Have a good day.
Have a good one. Bye.
Good day. Bye.
Bye bye.